Hi everyone. How are you guys doing? Can you hear me? Oh, great. Hi, Yasmin. I'm doing fine. Thank you for asking. Hi, Queenie, Fatima, and everyone. Hi, Tao. I'm doing, oh, I'm doing great by the grace of God. So, today's our last class. I will miss you guys. We had the wonderful semester together. You guys were very patient with me. I really appreciate all that. And you are also very sympathetic toward me always. Thank you so much for that. Okay. My goal for today is to give you as much information as possible to help you pass the final exam with an excellent grade. So your last chance to improve your grade is the final exam. So make sure you study every question very carefully. No quitting. Today is our last class. From Monday, final exam starts. So our final exam will be exactly 1 week from today, on next Wednesday at 5:20. So our class will start at 5:20. The exam will be till 7:20. There will be 8 questions, no multiple choice, no fill in the blank, all math questions. But all the math questions are bigger because they have multiple parts. And one of them definitely will be ANOVA, what we did in our last class. And ANOVA worth many points. I don't remember. I forgot already the points, but I remember it was a big point, 15 to 20 points on ANOVA. So you cannot skip your ANOVA question. You have to do the ANOVA one. And since it's only 8 questions, so every question worth so much points. It's not like my in-class exam where I have 2 points for each part. So whether you get perfectly, you get full point, or if you don't get perfectly, you get half point. It's not like that. It's huge points on every question. So if you make a mistake, and if the question is like hypothesis test, so the next part is based on the previous part. So if you make one mistake in the previous part, that means the rest of the part you'll make mistake. You have to be very careful. How many questions total? 8 questions with multiple parts, like A, B, C, D portion. So total 8 questions, but they have A, B, C, D, E, F, G, something like that. So, any question before we start? And it will be in our classroom, regular classroom. I cannot tell. You can write them down or take a picture, but I cannot actually. Okay, so any question before we start? How big of a portion is the last chapter? You mean 15? From chapter 15, there'll be only one question, ANOVA. The table we did in our last class, do you remember? The table, a scenario will be given, and then a table will be given. In this table, only 2 or 3 numbers will be given. You have to fill out the entire table and then do a hypothesis test. So hypothesis test will be just like chapter 11 or 12. You're going to make 2 hypotheses, alternative and null, then find the test statistic. The test statistic you will find based on the table, and then critical value, and compare them. and then conclusion. Okay. It's actually not bad. ANOVA. See, we did 4 examples, 3 examples, I don't remember. But I found them just like treasure hunt. Something somewhere is there. You have to find out how to find them out. Okay, you have to figure out how to find them out. So think of it as a game. It will be easier for you. Yes, I'm going to post this recording. And if you haven't seen the new channel on there, if you type my name, and then you will see this. This one is the new one. Thank you, Kiss. Yeah, I received many emails from many of you guys. I couldn't able to respond to all of your emails because so many things are going on since the final week. So thank you so much, everyone. What I was doing, okay, final. If I want to ask a question about the homework, should I ask at the end of the class? Sure, Mia, no problem. I'll stay. Okay, let's start. So first question, a bunch of points, not points, sorry, bunch of numbers are given as our data point. We need to do 5-number summary. That means you need to know what the 5-number summary, what 5 things we have in the 5-number summary. Do you guys remember? What do we include in the 5-number summary? Minimum, maximum, median, lower quartile, upper quartile. Perfect. But in order to do that, what is our first step? What do you have to do? We must arrange them in an increasing order. To make our life easier, I actually have them in order here, but in real life, they won't be in order. So first step, make them in order. Once you put them in increasing order, then the smallest number is the minimum, the largest number is maximum. And now to find median, if it's odd number, it's exactly the middle number. But if you have even many data, then it's the average of the middle two. So to find them out, the way I do is I cancel one from the left, one from the right. Left, right, left, right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that means this is a misleading question. I don't have 20, I have only 11. But let's say I have 12, so that I can show you how to find the middle when we have even numbers. Let's do here 22. So in this case, our maximum will be 22, minimum is 2. And then once you keep canceling one from the left, one from the right, we left with these 2 numbers in the middle, 11 and 12. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yep. So to find median, we do 11 plus 12. We take half of that amount. We get 11.5. So this is the median. Now to find the lower quartile, it means the middle of the first half. So we take 1 from the 2 middle and include that in the lower quartile. So in the lower part. And we take the other number and include that into the upper half. And then we do the same process again. We keep cancel one from the left, one from the right, one from the left, one from the right. And we got another 2 numbers in the middle. So we do the same process. 5 plus 8. We take half of that. 8 plus 5 is 13. Half of 13 is 6.5. To get the other half, we do the same thing. Cancel 1 left, 1 right, 1 left, 1 right. And we have 2 middle. So 15 plus 18, half of that It's 33, so it's 16.5, right? 8 plus 5 is 3, 1, 2, 3, so 33 is 16.5. Yep. So, in other words, what do we have? We have, this is 25% of the data. The median gives us 50% of the data, and upper quartile gives us 75% of the data, right? This is what it means to be a lower quartile and upper quartile. It's a lower 25 and upper 25. And exactly in the middle, the median gives us 0.5, which is 50%. Now, IQR, it's the upper quartile minus lower quartile. In other words, it's 75% minus 25% of the data. Now for 75%, we have 16.5. For 25%, we have 6.5. So we get 10. Our inner quartile range is 10. We subtracted lower from upper. Lower means 25%, upper means 75%. Now, if you understand this, the next table is easier for you to understand and solve. We are given a bunch of numbers, and all of these are percents. 50%, that means this is our median. 25% means this is our lower quartile. 75% means this is our upper quartile. If you can understand this, it doesn't matter what table they give you, you can answer any questions for the table. In here, they want us to find what's the median systolic blood pressure for the age group 60 to 69. Now, the second row gives us the age group 60 to 69. In other words, they're asking in the second row, what is your median? Means 50%. So in the second row, we have 135 BP as our 135 millimeter mercury as our BP. So our answer is 135. Okay, I'm not doing any math. I'm just looking at the table and getting the information from the table. The next one is asking for IQR for the age group 50 to 59. Now, age group 50 to 59 is the upper row. So how can we find IQR? IQR means it's 75% minus 25%. So for 75%, we have 140, one decile, and 25% we have 120. In other words, we need to subtract 140 minus 120, that gives us 20. So our IQR is 20 millimeter mercury. The next one, they're asking for what percentage of the people in the age group 50 to 59 have the BP level from 105 to 150. Now they're doing other way around. They are giving us the BP level, the blood pressure level. They want us to find out what percentage gives us this information. Now 50 to 59 is the first one, the first row. In this first row, they are asking us to look at the BP level 105, which is here, and the BP level 150, which is here. Now, for 105, we have 5% people. For 150 BP level, we have 90% of the people. In other words, we have 5% here, 90% here. So what percentage of the people have the BP level from this to that is basically subtracting the smaller one for the bigger one. Good job, Xian. So we have 85%. Okay. And we have one last one for the second one. So I used black. So for the age group 60 to 69, which is the second row. Now we are finding what percentage of people we have 115 to 145 BP level. Now 115, let me change the color, is here, and 145 is here. My Microsoft Word is giving me trouble. So 145 here, 115 here. 115 gives us 10%. 145 gives us 75%. So all we have to do is subtract 10% from 75%. Wonderful, Fatima. So 75% minus the 10% gives us 65, 145. 65%. Okay. Now, what do you think? If you've seen a similar table, would you be able to answer any question like this in the exam? Is there anybody who is confused about any of the parts we just explained? If you have a question, feel free to ask me anytime. I want you to ask me now, because if you ask me anything during exam, I'm not going to answer you. So ask me now so that I can help you clarify things for you for the exam. Okay? Yep. Now, from chapter 6, there'll be at least 3. I don't remember exactly how many, but I remember at least 3. It could be 3 or more than 3. That means chapter 6 is the most important chapter. So I posted all the video from chapter 6. We went over chapter 6, I think, with 3 videos. So make sure, if you forgot everything, see, here is our playlist. And we have chapter 6 here. Lecture 6, 7, 5, 6, 7. All of these 3 lectures are based on chapter 6. Make sure you do all the questions from chapter 6. I want to have a reading lecture. So here I put together basic information if you already forgot. If you are working with not disjoint events, then our addition rule is, if you have 2 events E and F, the addition rule is probably to the first one plus the second one, and we subtract the intersection. Now, if we are working with disjoint events, that means the intersection is nothing. We have nothing for the intersection, so probability of A and B is 0. And when you talk about independent, we talk about that the intersection will give us the product of the individual probabilities. So probability of A and B is probability of A times probability of B. So if they ask you, determine whether these 2 events are independent or not, all you have to do is find out what's the probability of A and B, and what's the probability of A, what's the probability of B. If you multiply probability of A and B and you get the same thing as probability of A and B, that means they are independent. Otherwise, they are not. And if they're asking whether find out whether they are disjoint or not, all you have to do is find out the intersection. If the intersection is 0, they are disjoint. If it's not 0, they are not disjoint. Okay. So when you talk about disjoint or not disjoint, we talk about addition rule. And when you talk about independent events, then we talk about multiplication rule. For multiplication rule, the probability of the intersection is probability of A times probability of B. Make sure you have all this information written in a cheat sheet. And now question number 1. We did this before in our lecture. We have a big restaurant and we have total 90 people. So why I'm saying 90, 900. So we have total 900 people. in this 900 people, let's say this is chicken and this is beef. Now in this 900 people, how many? 400 ordered chicken and 700 ordered beef, and 200 ordered both beef and chicken. Now they're asking draw a diagram and figure out whether they are mutually exclusive or not. Mutually exclusive means disjoint. So are the events ordering chicken and ordering beef, are they disjoint events or not? Well, just by looking at the Venn diagram, we already can see they are not disjoint because the intersection is a number. In order to be disjoint, intersection has to be 0. But in here, for the intersection, so this is probability of beef and chicken. I should actually write down this so I understand better. Probability of beef and chicken is 200. Now, if you find out the other pieces, it will be easier for you to answer any questions. So if the total is 400 and our intersection is 400, 200, so this small piece is 200. Here, this piece is 200. Now, if the entire beef is 700, that means that small piece is 700 minus 200, which is 500. Now we have total 500 plus 200 plus 200. That gives us entire 900. So there is nothing left extra. All 900 people, either they use chicken or they ordered beef or they ordered both. Okay, there isn't anyone who ordered something else. Now, if you understand the scenario, it will be easier for you to figure out the next question. Are the two events independent? Okay, you'll answer this later. First, answer this. If you randomly ask a customer whether he or she ordered, what's the probability the customer ordered chicken? And what's the probability the customer ordered beef? In other words, we are looking for what's the probability of chicken and what's the probability of beef. Let me write beef. Okay. So if you remember, to find the probability, we always take the denominator as the entire sample size. And from 900 people, we know 400 ordered chicken and 700 ordered beef. So this is 400 and this is 700. So 4/9, 7/9. And then the next one says, what's the probability that the customer ordered both chicken and beef? So probability of beef and chicken. Now it's clearly saying here that 200 ordered both chicken and beef. So it's 200 over 900. In other words, 2/9. Now we can answer B. In order to find out whether two events are independent or not, we need to see the intersection and their product. So probability of beef and chicken, how much is this? And probability of beef times probability of chicken, how much is this? So beef and chicken, we know it's 2/9. Probability of only beef was 7/9. We found it here. Probability of chicken is 4/9. We found it there. So when you multiply them, we get 28/81. Obviously, they are not same. In order to be independent, these two quantity has to be same. But since they're not same, so they're not independent, and here they are not disjoint. Okay. Now they want us to know what's the probability that customer ordered neither chicken nor beef. You can answer this either logically or using math. If you answer this using logic, we noted before that we had 200 plus 200 both plus 500. So this was chicken, half of the chicken. This portion was both, and this was beef. When we add all of these, we got 900 out of 900. We had 900 people, and everyone ordered something from beef or chicken or from both. Okay. In other words, there's nobody extra person left. So probability of neither is 0. If you have some portion left, then probability of neither will be that number divided by total. Okay. Now comes conditional probability. They're asking, suppose you ask a customer who ordered chicken. Now, what's the probability that the customer also ordered beef? So you know that someone ordered chicken. You approached him and asked him, hey, I know you ordered chicken. Did you also order beef? So what's the probability of ordering beef given that that person already ordered chicken? So it's a conditional probability. So conditional probability, if you remember, it's probability of their intersection divided by probability of what already happened. So probability of B intersects C over probability of C. Now B intersects C means probability of both chicken and beef. So we know 200 people ordered both chicken and beef. And how many ordered only chicken? 400. 400 ordered only chicken. So from here, we get the probability 1/2. Okay. Any question? I actually did a shortcut. If you want to do in details, probability of beef and chicken was 200 over 900. And probability of chicken was 400 over 900. So it's 200 over 900 divided by 400 over 900. So let me erase all these zeros. So it's 2 over 9 times 9 over 4. They cancel out, and this becomes 2. That's how we have 1/2. Okay, but you can do it shortcut. In exam, you may not have enough time to do all the details. Do it shortcut. Now, I go to the last one. Suppose it's a customer who ordered beef. Now, what's the probability that they ordered both beef and chicken? So probability of both, given that the person already ordered beef. So someone ordered beef, you went to him and asked, hey, did you order both? So it's probability of well, if he ordered beef, then probability of ordering both means simply probability of ordering chicken, right? If he only ordered chicken, that means he ordered both. So probability how can I say this? Divided by probability of beef. Does it make sense to say probability of both over probability of beef? What do you think, guys? If you already ordered beef and you're asking, did you order both? That means we are asking him, did you also order chicken? Probability of chicken over probability of beef. Probability of both is 2/9. Probability of beef was what? 7/9? Yeah. So it's 2/7. And if you do chicken, our chicken was 4/9, 7/9, 4/7. Which one makes sense? I think both make sense because it's both and beef. Now in both we have beef, but in chicken we don't have beef. Yeah, chicken doesn't make sense. It's probability of both and beef over beef. In other words, probability of both over probability of beef. Yeah. Okay. Question? No. The next one. We have a bin with 2 blue and 4 green, and we are picking 2 randomly, and we want to know what's the probability of 2 blue balls. Well, they did not mention whether it's with replacement or without replacement, but if you use common sense, then you can already see it actually without replacement. So we have 2 blue and 4 green. Probability of picking 2 blue. If you take 2 blue out, that means you are picking them without replacement. So it's without replacement indirectly, they're telling us. So we have probability of first blue times probability of second blue. Now, since it's without replacement, every time we are picking something out, our denominator is reducing by 1. So for the first blue, we have 2 of them, total out of 6. So we have 4 plus 2. Total ball is 6 in the bin. And the first time we are picking a ball to have a blue, we have 2 choices out of 6. Now, once we pick that out, we have the second blue. For the second blue, we have only 1 out of 5 left because you only picked the first one. So in the bin, we only 5 balls left. So we have 1 out of 5 choices. In the next one, they are asking for 2 green. 2 green, same scenario. For the first green and second green. First green has 4 choices out of 6 total. But once we pick 1 out, then we have 3 choices out of total 5 balls. Now they're asking what's the probability of having the same color. Now same color, they didn't mention which color, blue or green. That means you have 2 choices. Either we are picking 2 blue balls, 2 blue, or we are picking 2 green balls. Okay. Now, probability of 2 blue or probability of 2 green. In math, all means union. So probability of 2 blue union to green, we represent that by a plus sign. Now, probability of 2 blue, we already did it on the left page. It's 2 out of 6, 1 out of 5. Probability of 2 green is 4 out of 6 and 3 out of 5. Okay. What's the probability that they have different colored? Now, different color means one of them has to be blue, one of them has to be green. So, either you have, so either first blue and second green, GREE again, or first green and second blue. We have two ways of having the two balls. Either first ball is blue, second green, or first green, second blue. So we have two choices. So you have two ways of doing it. You do 2 times them, or you write them individually. If you do 2 times that, actually let me do individually first. So first blue, second green. For the first blue ball, we have total 2 blue out of 6. And once you pick that out, we have 5 left in the bin. And for green, we have 4 choices. Now, or means plus. So and means multiplication. This and is here. Now, or means, so we are going to do the second part, first green. Now, out of total 6 green balls, we have 4 possible green. Out of total 6 balls, we have 4 possible green balls. And once you pick that green ball out, we left 5 balls in the bin. And in that 5 ball, there are only 2 possible blue. Now, if you observe, these are actually exact same 2 things. It means it's same as you're writing 2 out of 6, 4 out of 5 twice. Okay. So either you can do it this way in details, or you can simply write 2 times the probability once. Question? Now the next one, it looks horrible. That means you have to read very carefully. There are 3 directors who made 3 different types of movies: detective, sci-fi, or love stories. After watching the movies, viewers were asked to give their opinion on whether they liked or disliked the movie they watched. We have 50 people. In these 50 people watched detective. 30 watched sci-fi. 40 watched love stories. Now, among the 50 people who watched detective, 40 of them says they liked them. People who watched sci-fi, 10 of them says they disliked sci-fi. Like me, I hate sci-fi. From the 40 people who watched love stories, 30 of them says they liked love stories. Now, if you pick one of the viewer randomly, what's the probability that he or she liked the movie? They did not mention which movie, which type. They didn't mention that. They're asking they liked. What's the probability that they liked the movie? For this type of question, it's better if you organize them in a table so you can see everything in front of you. Okay. So we have 3 types of movies: detective, sci-fi, or love. And either they liked the movie they watched or they dislike. Okay, so we can find the total for both cases. Now 50, 30, 40. We have 50, sorry, my bad. 50 people watch detective, 30 watch sci-fi, and 40 watch love. They gave us a total number for all three scenarios. So if we add them up, we get 120. Right? 7 plus 5 is 12. Now, 40 people liked detective. So 40 people like detective. Oh man, come on. I hate this. Give me 1 second. Let me close it and reopen it. I hate it when this happens. This sucks. So 40 people say they like detective. 10 people say dislike sci-fi. And 30 people they liked love stories. Now we can find their missing pieces. So how many people disliked detective? Total 50 people watched, 40 liked. So how many disliked? Do you get the idea? The total 50 people, from 50, 40 people liked it. So 10 people, good job, Lazy. 10 people did not like it. Now, from the 30 people of sci-fi, 10 people disliked that. So how many liked it? 30 minus 10 gives us 20. Great. And the last one. 40 watch love stories. 30 liked them. So how many disliked love stories? 10. Wonderful. Now we need all of these because we need to add them up. 4, 5, 6, 7, 8, 9. So we have total 90 people here and 30 people here. Now when we have all the details, so these are total column. We need the total column because that will help us to answer any question. First question they're asking us, how many people, what's the probability that a randomly picked person liked the movie? In other words, they're asking for what's the probability of like. Now, probability of like means number of like divided by total, grand total. Now, 90 people liked out of 120. So that's the probability. Next, they're asking if you pick one person randomly from who liked their movies, what's the probability that they liked the love story? So it's a conditional probability. Probability of love story given that the liked love story. Sorry, probability of liked love story given that it's from the liked person. You need to make the table yourself. So that's what I said. You have to read the direction carefully. So yeah, for this question. Now, basically it's probability of liked love story divided by probability of like. Now, how many people liked love stories? Liked love stories is 30. Out of total people who like is 90. So we have 30 out of 90. In the exam, you're going to reduce your fraction, okay? I'm not doing it here because I want to finish everything possible. So probability of liked love stories over probability of like is 30 out of 90. Any questions so far? No. The next one. How many we have? Okay, last one. What's the probability that someone disliked their movies? And what's the probability that he was sci-fi, like me? That's it for me. So it's probability of sci-fi given that they disliked the movies. What's the probability they watch sci-fi given that they disliked the movie? So it's probability of disliked sci-fi over probability of disliked. So sci-fi dislike. So we have disliked 10. So sci-fi dislike 10. And probability of dislike is 30. So 10 people out of 30 people, they disliked sci-fi. Any question on this question? I'm rushing through all of this, so if you want to know details explanation, I would suggest you to watch the past recording. In there, I went slowly in details. Now the next question, it's very similar to the one we just did. In this question, they already gave us the table with two variables. One is either agree, disagree, and the other one is fan or not fan. And they want us to find what percent of the population is football fan. So they're not asking for probability, they're asking for what percent. What percent of the population is football fan? So football fan out of total population. We have football fan is this, or total population is this. So 1216 over 2096. Since they are asking for percent, you cannot leave your answer like this. You must find the quotient and write as an percentage. So let's see. 1216 divided by 2096. 58.2%. So it's 0.5801. That gives us 58.01%. Did I say 1 or 2? 01 is 2. because the next number is 5. Okay. So anytime they ask you for percentage, you have to give them the answer with percentage. Now, what percent is what percent of football fan disagreed? So we go to the total disagree column and we see what parts, how many of them are football fan. So 523 football fan, they disagree from 1174. So total disagree on the bottom, and on the top is from this disagree, how many of them are football fan. So go to the calculator, 523 divided by 1174. 44.55. 44.55%. Oh man, what percent of not football fan agreed? So it's agree, no, agree on the top and not fan on the bottom. So not fan is 880, and in the not fan we have 229 agree. Remember, when you find a percentage, the answer is always the bigger one. Denominator has to be bigger than the numerator. So anytime you find that numerator is bigger, that means you're doing something wrong. 229 divided by 880, 26.2. 26.2%. Okay. So when they ask for percentage, you need to divide right there inside the percentage. However, when they ask for probability, you can leave the probability alone. If you want to simplify, go ahead. If you don't want to, no problem. Now, probability of agree, it means total agree divided by total agree divided by total people. Now, total agree is 922. Let me change the color. 922. And the total people we have here is 2096. So 922 over 2096. That's the answer. Probability of D means disagree over total people. So for disagree, we have 1174. So it's 1174 divided by total 2096. Now the next two are conditional probability. So it's probability agree and a football fan divided by probability of football fan. Now agree and football fan. Let me change the color again. Oh, did I do wrong? B. 523 1216. Disagree. No, they're saying in B, what person are football fan? Disagree. So fan over disagree. Fan over disagree. So fan is 523, right? And disagree is 1174. Do you see that, Shion? from all the people who disagreed, what percent of them are football fans? So people who disagree, the amount is 1174. Among these 1174 people, 523 of them are football fans. Okay, now what I was doing, agree and football fan. So let me change the color, something like this. Agree and football fan. So agree and football fan is here over football fan. Football fan is here. So agree and football fan divided by football fan. I forgot the number, 693, 1216. 693, 1216. So agree football fan over football fan, right? Agree football fan over football fan. The next one is asking for agree and not football fan. So probability of agree and not football fan divided by probability of not football fan. FC means it's F complement, it means not F. So agree but not a football fan. Agree but not a football fan is this 229. And total not football fan. Not football fan is this one, 880. So it's over 880. Okay. Question? No question? Okay, now comes ZT thingy. So make sure you write down all the details in your cheat sheet, okay? From every section. Now in here, they're asking, suppose we have a chromosome defect once in every 6 adult, Caucasian adult. Now P is the proportion of the male with chromosome defect. Find mu of P. So mu of P, that means we are looking at here. Mu of P is P, which is the success rate. So success rate, if they don't give you the number already, that means you need to find it from the p hat. So in here, they give us p hat. So mu of p, so mu of p hat is p. In other words, it's 1 out of 6. Yeah. So from this information, this is what we have. So it's not p hat, it's only p, because they're talking about population. In a population, once in every adult, once in every 6 adults get chromosome defect. Now, in a random sample of 30, does the sample proportion have approximately normal distribution? So if we have a 30 sample size, do we have enough people to have approximately normal distribution? In order to check this, we need to know what is n times p and what is n times 1 minus p. The condition says in order to have a normal distribution, their product has to be bigger than 10. At least 10 or bigger. Now, in order to have a normal distribution, how many people we need is 10 divided by p which is 10 divided by 1/6. Keep, change, flip. That tells us is 10 times 6/1, which is 60. So we definitely need 60 people at least 60 people in order to have normal distribution. That means n is 30 is too low. So we don't have enough people to have a normal distribution. Next, they are asking, what is the smallest number of n for which the sample has to be normal? Well, we already calculated that here. Our n has to be at least 60. So either 60 people or more than 60. Yeah. If you want, you can actually answer this in a different way. You can find out what is n times p. Our n is 30 and our p is 1/6. That gives us 5. 5 is not more than 10. So we don't have normal distribution. How many people we need? Solve for n. What are the mean value and standard deviation of the sample proportion p hat based on the size 60? So we want to know the mean value and the standard deviation of p hat. So mean of p hat and standard deviation of p hat. You don't have to memorize because all the informations are here. Mean of p hat is same as p. So it's same as p, which you already found. It's 1/6. Now sigma of p hat is p 1 minus p over n under the square root. So p 1 minus p over n under the square root. That means it's 1/6, 5/6, and we have total sample size 60 under the square root. So 5/36 times 60/1, whatever that is, that's the answer. Okay. Next, they are asking for N60, what is the probability that our p hat is between 0.30 and 0.50? Now 1/6 is what? 1/6 0.17, close to 0.17. They want us to find what's the probability that our p hat is between 30 and 50. For this case, you need to get the help of the z. We want to normalize this. So what we do probability of p hat is smaller than 0.5 minus probability p hat is bigger than or equal to 0.30. So we are going to find two probabilities and separate the smaller one from the bigger one. Now, in order to get this probability, we go to z and say, hey z, tell me what do we have from your distribution. So z is less than x minus, there's the formula here. This one for mean, and this is for proportion. So p hat minus p, our formula is p hat minus p over square root of standard deviation, which you already found here. Okay. Sorry, only standard deviation, because standard deviation already has a square root. Right? Right. Yep. So it's p hat minus p over standard deviation. And we are going to use this formula twice. Once is for 0.5. 0.5, and we have 0.17. That is our P. Divided by standard deviation, I don't have the number, so let's find it. I'm too lazy. 5 times 60 divided by 36. Whatever we have, take the square root. 2.89. 2.89 minus probability z is less than 0.3 minus 0.17 over 2.89. And then you find a z value. Probability of z is less than something minus probability of z is less than something. So what you do, you go to the z table for both of them and see what their values are. And then you write them down here, subtract the smaller one from the bigger one. Whatever you have, that's the answer. Okay. We did this question in class, so if you need the details, go watch the recording. Now, chapter 9, we are doing interval notation. Sorry, we are doing what is called confidence interval. Remember, for confidence interval, our alpha is always two-tailed. Okay. Okay. What type of question you expect to see is the question we have in our exam 2. The owner of restaurant is observing something, and they want us to find out 2 things for them. First, they are observing how much money each customer spent, and then how many customers order dessert. Now they observed 60 people. In our second exam, we had a similar question with the workout scenario, the gym scenario. Gym scenario and this scenario, they're the exact same thing. So they're observing total 60 people. In these 60 people, 18 of them purchased dessert, and the mean and standard deviation for these 60 people is given here. First, they want us to construct a 99% confidence interval for the mean money they spend on the restaurant and interpret the confidence interval. So since you're working with mean, that means you are going to use X bar. So we have N60 and our alpha is 1 minus 0.99, which is 0.01, 2 till 0.01. Our degree of freedom is 60 minus 1, which is 59. So we go to our t table and set t 2 tilde alpha with degree of freedom 59. We go to the t table. Let's do it. T table. So our t is here. Degree of freedom is 59. We don't have 59, we have 60 here. And our alpha is 2 till 0.01. 2 till 0.01, yeah. So 2 till is here, the second row. 0.01 is here. And our 60 is here. This column. So it's 2.66. So we got to 2.66 here. And our formula is X bar plus minus T, and then T and S over square root of N. S over square root of n. So remember, many of you could not able to find the correct answer using the formula because you entered your information in the calculator. So when you enter, make sure you do the inside first, multiply by the t, and then you are going to add or subtract the x bar. Okay. So in here, they're telling us our x bar is 38. I hate this. 38.54, and our S is 7.26, and our N is 60. So substitute everything, whatever you have, that is your answer. When you interpret, it means we are 99% confident that the true mean of the true mean amount spent, people spent in the restaurant is between this dollar to that dollar. My ink is not working again. Now the next question they want us to answer is about the proportion. From the 60 people, 18 of them ordered dessert. Now construct 95% confidence interval. Let me close it and open it again. So since here 18 out of whatever people ordered dessert, that means this time we are working with proportion. Anytime you're working with proportion, we cannot use t, we have to use z. So we are going to use 2 till z. And remember I gave you the 1 till and 2 till for z before. You can simply have this in your cheat sheet and use that. I don't have the table here, so I'm not going to do the math. I'm just going to explain you the rules. So proportion, we have p hat. 18 out of 60 people ordered that, so p hat is that. And in this case, we need to use z 2 till our alpha is 0.05. 2 till alpha 0.05. Okay, so 1 minus 0.95 gives us 0.05. Now the formula here will be the p hat formula. P hat plus minus z sigma. Why is our proportion here? P hat 1 minus p hat. P hat 1 minus p hat over n, everything under the square root. So when you find the number, make sure you find this first, take the square root, whatever you have, multiply by z, and then with that quantity, you add the p hat, and then you subtract the p hat from, subtract this quantity from the p hat. Okay. And when you interpret, you say, well, we are 95% confident that the two proportion of customers who ordered dessert lies between these two numbers. What you found here. From chapter 10, we have hypothesis test. So chapter 10 has many choices, many possibilities. How many I have here? 2 of them I have here. So we have something like this. A teacher set a maximum time limit of 120 minutes for completing a group project presentation. This is a very important question, okay? So make sure you pay attention to this question because this is kind of confusing. So a teacher has set a maximum time limit 120 minutes. So maximum time limit is 120 minutes, okay? And each student in a group is expected to speak for an average of 8 minutes. So each student have 8 minutes. Now the total time they're going to spend in the presentation is 120 minutes. So average 8 minutes with standard deviation 2 minutes. Now, the speaking times are approximately normally distributed. If there are 15 students in this group, what is the probability that the total speaking time will exceed the time limit? Oh man, is it a probability question? Okay, let's see. If there are 15 students in the group, so each student has 8 minutes. So for 15 students, we have 8 times 15, which is about 200. 8 times 15. Oh, 120. Really? 8 times 15, 120. Okay. I think I did something wrong here. 8 times 15. Yeah, probably when I wrote this question, it was, let's say 16. Okay. If it's 16, then we have 128. 16 times 8. We need 128 minutes. Now we are finding what is the probability that the total speaking time will exceed the limit. Our limit is 120 minutes. What's the probability that we'll have more than 120 minutes? I feel like something is wrong with this question because this should fall under chapter 10, and chapter 10 doesn't have probability. So probably this question was something like this. Is there enough evidence? Oh man. I don't even know like how it's fall under chapter 10. Each person has 8 minutes with 2 standard deviation. Okay, so since I'm confused, I'll just say, okay, let's say we have actually let me skip this. I will white's here. Is it a typo or there is something is wrong with this question? And then I will send you the solution for this question with the correct version. Okay. So this is a very important question, but I think something is wrong with this question. So let me skip this. How many more we have? 2 more. Yeah, 2 more. So I'm going to go through real quick. A study was conducted by the researcher at University of investigating whether time perception, an indication of a person's ability to concentrate, is impaired during nicotine withdrawal. This wasn't from our exam two, it was from my previous exam two. We had 20 smokers were asked to estimate how much time had passed during 45 seconds period. Suppose the resulting data on perceived elapsed time has a mean of this standard deviation that. Do the data from this study provide enough convincing evidence that the population mean estimated time is greater than 45 seconds? So null hypothesis. Our mean is, null is equal. Mean is equal 45 seconds. So our claim is it's greater than 45 seconds. Okay, and we are going to do a t-test because we have x bar with sample standard deviation, and we have total 20 people which is a small amount. So T-stat is x bar minus mu over s over square root of n. Our x bar is 59.4. We have mean is 45. S is 9.86 square root of 20. So make sure when you solve it, you solve this fast, or use a parentheses when you put everything together. If your calculator doesn't have a fraction format, whatever you have, you write it down. Then to find T critical, we have degree of freedom 20 minus 119, and this tells us that we have one-tailed alpha. So one-tailed alpha with degree of freedom 19, whatever we have, we get it from the table. Now, if T-stat with the absolute value is bigger than T critical, we reject the null hypothesis. Rejecting the null hypothesis means we are rejecting this. As a result, we have enough evidence to support the alternative claim, okay? Because we are rejecting the null. So we have enough evidence to say that our mean time is bigger than 45 seconds. The next type of question is before and after. So remember, you must know how to find the standard deviation. Okay. So the formula for the standard deviation is x minus x bar square over n minus 1. And then take the square root. So for this type of question, you're going to subtract. It's better to do the result from before, okay? So after minus before, if you do it, it will be more logical. So you subtract 90 minus 10, 80, and then you do all of this, okay? Find this, find the x bar, which is you add all these differences and divide it by 6. Whatever you have, that goes here. So for x standard deviation, it's 80 minus x bar square plus next one is 8 minus 1, 60. No, 5 minus 5, 70. So 70 minus x bar square. So you keep doing that, divided by n minus 1. Whatever you have, that's your standard deviation. Now, why do you care? Because that standard deviation comes here. That x bar comes here. So this is x bar d and standard deviation of the differences. Now, hypothesized value here. So null hypothesis is your mu difference is 0. It means you have no difference between before and after. And alternative hypothesis, mu difference is based on what they're asking you. In here, they're asking, is there evidence that the lecture is effective as a student claim? So student claim that they do better in the exam. That means the result is a positive result. So mu d is positive. Now in your case, maybe like in my in-class exam, I had two-sided decision. So if it's two-sided decision, you do an article sign. And if it's one-sided, it's bigger than 0 or less than 0, depending on what you have. What I was doing. So you substitute everything here. So your hypothesized value will be 0. Your x bar is what you get in step 2. Your standard deviation is what you get in step 3. And your n is square root of 6. 6 is n to square root of 6. Once you do that, you find T critical. So in here, our degree of freedom is 6 minus 1, 5. And it doesn't matter whether if we bigger than sign or less than sign. It doesn't matter. Both of them tells us that we have one tail alpha. So it's one tail alpha level what? If they don't mention your level, then it's always 0.5. Okay. Probably they will. As far as I know, they will mention it. If they don't mention, remember it's 0.5. So you go to the T table, 1 till alpha 0.05, you get the critical value, and you do the same thing. Compare them. And if you reject the null, it means this is not true. So we have enough evidence that yes, that the videos are effective. But if you fail to reject, that means we don't have enough evidence that the videos are effective. Okay. Chapter 12, you can ignore chapter 12. There won't be any question. But remember to do chapter 15. And we don't have time, so for chapter 15 in details, go watch the previous recording. Okay. So make sure you do our in-class exam 1 and 2, all the questions in there, and the review sheet, and these questions. I'm not going to post this, but I'm going to post a lecture video so you can see everything in the recording. Thank you for staying, guys. Any question? I went through real quick because we didn't have much time, but all the details of everything we did here, you'll see them in our in-class recording. Okay, Fatima.
Professor, you said you're not going to post this recording?
I will, but I'm not going to put the lecture slide.
Okay. Thank you.
Yes, in this exam, you're allowed to have two-sided cheat sheet. You can put anything you want. But study harder, smarter, okay? It should be as simple as possible so that whatever information you need, you can able to find them during exam. 8 questions with multiple parts is a lot. So you only 2 hours. Any other question? No? Then Mia, go ahead. Ask me about your homework question.
Hi.
Oh, I forgot to tell you. I extended the homework for 1 more day. So make sure you finish everything before the 13th. Go ahead, Mia, sorry.
So I finished like all the homeworks, and then I was just gonna leave like this question blank because I didn't get it. But for chapter 7, like question 9, I don't understand. Like I can't get the answer. Should I like send it to the chat or something?
I can open here.
Okay.
Let me actually pause the recording. Oh, no, not the meeting. Shh. What I was doing? Oh.